Hello, this video is going to describe your assignment for the week. I thought it would be easier just to do this in a video than to try to do it um, in text that may not be as clear. So this is a file that has a lot of rows. Let's see how many we have for real. 1,437 rows. And what they are is used Toyota Corollas that are being sold. And so we want to try to figure out if we can build a model. This is old data, this is old training data, and we're going to use this old training data to build a model that will allow us to price out Toyota Corollas when they come for sale in the future. Again, the idea is that we don't want to leave money on the table if we price the car too low, and we don't want to price the car too high because then customers won't buy it. So it's pretty clear then if we are going to use this in a linear regression model that the output variable is going to be our price. So for all 1,437 of those records, we're going to take a look at the price, and that's going to have been influenced by a couple of things. And I'm going to give you a subset of variables that I want you to look at. We're going to do first a simple linear model, and then we're going to do a multiple linear model. Okay. The first thing I want you to do is I want you to build a model with price as the output variable and the kilometers as the input variable. Okay? Is there a relationship between the number of kilometers on the car and the eventual price that the car has sold for? And when you do that, you're going to come up, you'll drop those numbers in JASP. This is in a CSV, so it'll be easy to load into JASP. You will come up with a slope and an intercept. What I would like you to do is go all the way over to the right. There's a bunch of stuff over here that we don't care about. And put in your simple linear model. And you know what your x is, right? Your x is the price. So go ahead and grab that from over on the left side. And that price, well, actually, forget that. Don't worry about the price. You want to know what your x is. Your x is the kilometers. That's what it is, kilometers. So go ahead and grab the kilometers from the left-hand side. And then you're going to do something that looks like this. You're going to be y equals your intercept plus your kilometers times your slope. But convert that into numeric values, right? So if your intercept is, let's say your intercept for just sake of argument is 25. So you put 25 here instead of the word intercept. Pull the kilometers by referring to the appropriate cell, and then go ahead and put in the value that the model gives you for slope. And then I'll give you a little hint. If you get it in here correctly, and it would be, of course, equal sign, instead of the y, you'll have the equal sign will be your value here. You can position your box on top of that value. If you double click this little green box in the corner, it'll fill in all of those values, adjusting for the appropriate cell counts for the kilometers all the way down to the bottom. So that's one way of doing it. So then the next thing I want you to do is I want you to go back. Okay, we've already built a model for price as determined by kilometers. It would be really nice if you go back and you would say, okay, take my predicted price, and this will be our next one. So we're going to call this error. And we might be specific about simple linear regression error. But I'm going to take, that's going to be equal to price, whatever the price cell is, minus whatever I have in AN2, which is my prediction, right? And I'll be able to see what the difference is. Okay, so I can see what all my errors are. Okay, so we're going to do the simple linear model, which is our y equals intercept plus kilometers times the slope, and then we'll use the actual price and subtract our prediction to see how close we are. Then we're going to take it one step further. I'm going to go back here, and I'm going to get rid of this because this is going to give me an error, but we're going to do a multiple linear regression model, and we're also going to do an error. RROR, let's spell it correctly. So we're going to go back here, and now we're going to look at three things. We'll see how close our model is when we just use kilometers. But I also want to look at a couple other things. So we're going to do a multiple linear regression model. we're going to look at, we'll keep kilometers, but we're also going to look at the age of the car. So that's your second variable. And we're going to look at the weight of the car, which will tell us kind of how big, how heavy the car is. When we do this model, remember, we are going to pull this file into JASP. We will have kilometers, we will have age, and we will have weight. We will get one intercept and 3 slopes, one for kilometers, one for age, and one for weight. So what that means is you've got to take all 4 of those values, go all the way over to the right, and build your model. So your predicted value, y, is going to be equal to your intercept plus kilometers times slope, its specific slope, plus age. I'm going to abbreviate age. It's got numbers attached to it, but you'll know which field it is, times its slope, plus weight times its slope, and that will be your predicted value. That will be your y value. Okay. When we do that, we'll have predictions that are hopefully closer to the actual sale price, because now we're using more informed, I gotta fix this, left out the parenthesis, more informed predictions. So we can go ahead and then calculate the error again. We can take the actual price, which is noted over there on the left, and we can subtract from that the AP, get that calculation right in AQ2, and then hit the little green box and cascade it all the way down to get it to make it go all the way to the end. When you're done and you have the columns AN, AO, AP, and AQ populated, turn this in as your assignment for the week. This is going to be what you submit, and that should finish you out. Of course, let your instructor know if you run into any problems or questions, and good luck on this assignment.